Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi, my name is Neil McIsaac. I'm a Microsoft technical trainer within Worldwide Learning here at Microsoft, and I'm responsible for providing technical skilling on Microsoft's cloud technologies to our top enterprise customers. I've been in the IT industry for over 30 years now, and I've been supporting Azure since 2008, which is about 2 years before Azure was generally available to the public. And with that, I'd like to welcome everyone to this Microsoft Azure Virtual Training Day course for Azure Fundamentals. This course is divided into 6 sessions across 2 parts. Part 1 starts with Session 1, where we'll explore cloud fundamentals. In Session 2, we'll discuss the Azure architecture and Azure Compute Services. We'll wrap up Part 1 with Session 3, which will cover Azure Networking. After Part 1, we'll begin Part 2 of the course with Session 4, which covers Azure Storage. And in Session 5, we'll explore identity, access, and security within Azure, as well as Azure Cost Management. Then finally, we'll wrap up the course with Session 6, where we'll cover Azure Governance and Compliance, Azure Resource Management, and Azure Monitoring Services. With that, let's get started with Session 1 on Cloud Fundamentals. In this first session, we'll start by introducing what cloud computing is and what makes it different than traditional computing. We'll then discuss some of the benefits to using cloud computing before we wrap up with a rundown of the 3 general types of cloud computing services. So let's get going with our first learning objective on cloud computing. Cloud computing is a model that enables on-demand access to a shared pool of configurable computing resources. These resources can include servers, networking, storage, applications, and many other services. This model allows organizations to efficiently manage and scale their IT infrastructure without the need for significant upfront investments. Cloud computing is characterized by its ubiquitous, convenient, and on-demand network access. This means that users can access computing resources from anywhere, at any time, using any device with an internet connection, and do it securely. This level of accessibility is crucial for modern businesses that require flexibility and agility in their operations. One of the most significant advantages of cloud computing is its ability to rapidly provision and release resources with minimal management effort or service provider interaction. This means that organizations can quickly scale their IT infrastructure up or down based on their needs, without the need for extensive manual intervention. This agility allows businesses to respond to changing marketing conditions and customer demands much more effectively. Cloud computing offers a powerful and flexible solution for managing computing resources. Its on-demand access, ubiquitous network availability, and rapid provisioning capabilities make it an essential tool for any modern business. Private cloud computing is a model where the cloud environment is owned and operated by the organization that uses the cloud resources. This means that the organization has full control over the cloud infrastructure and can customize it to meet its specific needs. In a private cloud model, organizations create their cloud environment within their own data center. This involves setting up the necessary infrastructure, such as servers, storage, and networking equipment to support the cloud services that they want. By doing this, organizations can ensure that their cloud environment is optimized for their unique requirements. One of the key features of a private cloud computing implementation is self-service access to compute resources. This means that users within the organization can provision and manage the resources they need without having to go through a central IT department. This self-service capability empowers users and allows for greater flexibility and efficiency in resource management. While private cloud computing offers many benefits, it also comes with the responsibility of operating the services provided. The organization is responsible for maintaining the infrastructure, ensuring security, and managing the overall performance of the cloud environment. This requires a dedicated team of IT professionals who can handle the complexities of cloud operations, including provisioning and maintaining all of the hardware necessary to support the private cloud. Public cloud computing is a model where the cloud environment is owned and operated by cloud services or hosting providers such as Microsoft Azure, which is owned and maintained by Microsoft. The cloud provider is responsible for maintaining and managing the infrastructure, ensuring that it's always available and secure. The public cloud provides resources and services to multiple organizations and users, allowing them to access compute, storage, and applications without the need for significant upfront investments in hardware and software by the customer. One of the key advantages of public cloud is its scalability. Organizations can easily scale the resources up or down based on the needs without having to worry about the underlying infrastructure. This flexibility is particularly beneficial for businesses with fluctuating workloads or those that experience rapid growth. Access to the public cloud is typically provided via a secure network connection, usually over the internet. This means that users can access their resources and services from anywhere in the world as long as they have an internet connection. This level of accessibility is crucial for modern businesses that require flexibility and agility in their operations. In addition to scalability and accessibility, the public cloud also offers cost savings. Since the infrastructure is shared among multiple organizations, the cost of maintaining and managing the underlying resources is distributed, resulting in lower costs for individual users. This makes the public cloud an attractive option for businesses of all sizes, from startups to large enterprises. However, it's important to note that while the public cloud offers many benefits, it also comes with certain challenges. Security and compliance are critical considerations as organizations must ensure that their data is protected and that they comply with all of relevant regulations. Additionally, organizations must be careful to manage their usage to avoid any unexpected costs. So, by leveraging the public cloud, organizations can achieve greater scalability, accessibility, and cost savings, while also addressing the challenges of security and compliance. Hybrid cloud models offer a unique approach to cloud computing by combining the benefits of both public and private clouds. One of the key characteristics of hybrid cloud models is resource location. In this model, some resources are located in a public cloud, while other resources are located within a private cloud. This allows organizations to optimize their resource allocation based on their specific needs and requirements. Cost and efficiency are significant advantages of hybrid cloud models. By leveraging the public cloud, organizations can benefit from the cost savings, efficiency, and scalability that come with it. At the same time, they can maintain critical and sensitive workloads in their private cloud, enabling them to meet security and compliance requirements that may not be possible within a public cloud. Control is another important aspect of hybrid cloud models. Organizations retain full control over their private cloud environments, allowing them to customize and manage their infrastructure according to their specific needs. This level of control is essential for organizations that require a high degree of security and customization. However, it's important to note that technical skills are still required to maintain a private cloud and ensure that both cloud models can operate together seamlessly. Organizations need a dedicated team of IT professionals who can manage the complexities of a hybrid cloud environment and ensure that the integration between public and private clouds is smooth and efficient. When comparing the three types of cloud, It's important to understand their unique characteristics and benefits. Starting with the public cloud, this model requires no capital expenditures to scale up, making it a cost-effective option for many organizations. Applications can be quickly provisioned and deprovisioned, allowing for rapid deployment and flexibility. Additionally, organizations only pay for what they use, which can lead to significant cost savings. On the other hand, private cloud offers organizations complete control over the resources and security, ensuring that their specific needs and compliance requirements are met. However, organizations are also responsible for hardware maintenance and updates, which can be very resource intensive. The hybrid cloud provides the most flexibility by combining elements of both public and private clouds. Organizations can determine where to run their applications, optimizing for performance, cost, and compliance. They also can retain control over security, compliance, and legal requirements, allowing them to meet their specific needs while leveraging the benefits of both cloud models. When considering the financial aspects of cloud computing, it's important to understand the differences between capital expenditures, or CapEx, and operational expenditures, or OpEx. CapEx involves spending on physical infrastructure up front, like buying servers. This means that organizations need to invest a significant amount of money initially to purchase that hardware and other infrastructure components. On the other hand, OpEx allows organizations to spend on services or products as needed. With OpEx, there's no need for a large initial investment. Instead, organizations get billed immediately for the services that they use. This pay-as-you-use model provides flexibility and helps manage cash flow much more effectively. The consumption-based model offers numerous benefits, the number one being no upfront costs. This means organizations do not need to make significant initial investments in infrastructure. Instead, they can allocate their financial resources more effectively. Additionally, there's no need to purchase or manage costly infrastructure that may or may not be used to its fullest. This eliminates the risk of over-provisioning and underutilization, ensuring that resources are used efficiently. Another key benefit is the ability to pay for additional resources when they're needed. This flexibility allows organizations to scale their operations up or down based on demand, without being locked into long-term commitments. Furthermore, the consumption-based model provides the ability to stop paying for resources that are no longer needed. This ensures that organizations only pay for what they use, leading to cost savings and better budget management. Hopefully, that helped everyone understand what cloud computing is a little bit better. Let's get started on our next learning objective on some of the benefits of using cloud services. Using cloud services brings several significant benefits, starting with high availability. This means that your application and data are accessible whenever you need them, with minimal downtime. Cloud providers like Azure have multiple data centers around the world, ensuring that your services can remain up and running even if one location experiences an issue. Another key benefit is elasticity. With cloud services, you can quickly adjust your resources to match your current needs. If you experience a sudden increase in demand, you can easily scale up your resources to handle the load. Conversely, if demand decreases, you can scale down to avoid any unnecessary costs. This flexibility allows you to respond to changing conditions without over-provisioning or underutilizing your infrastructure. Scalability is also a major advantage of using cloud services. As your business grows, you can seamlessly expand your infrastructure to support new users, applications, and data. You don't have to worry about the limitations of physical hardware or the complexities of managing a large-scale environment. Instead, you can focus on delivering value to your customers and driving your business forward. These features ensure that your applications and data are always accessible, allow you to adjust resources as needed, and support your business growth without the constraints of traditional infrastructure. Let's take a closer look at scalability and elasticity before we discuss more of the benefits of using cloud services. Scalability refers to either scaling vertically, which means scale up to a larger compute environment, or to scale down to a smaller compute environment. Or it can refer to scaling horizontally, which means increasing or scaling out the number of compute environments, or to decrease or scale in the number of compute environments. For example, if we have a virtual machine configured with 4 gigs of RAM, we could scale it up to 12 gigs of RAM. We could also scale that machine with 12 gigs of RAM down to a machine with only 8 gigs of RAM. Scale out means that we can add an additional machine of the same size, which effectively will double the amount of compute. And we can even add a third machine to increase the amount of compute even further. Remember that elasticity refers to how we trigger scaling to occur automatically. So an example of this might be if we have one virtual machine and we set a scaling rule to trigger it at the average CPU used percentage maybe goes above 80%. Then we can add a second virtual machine automatically. And then if that machine's CPU usage goes above 80%, we can add a third machine, and so on, until we have enough compute capacity to handle the job. So to recap, scaling vertically is about increasing or decreasing the size of the compute, and scaling horizontally is about increasing or decreasing the number of compute environments. And elasticity is about doing all of this automatically. Let's discuss more of the benefits of using the cloud. Starting with reliability. Cloud providers like Azure ensure that your applications and data are always available with minimal downtime. This reliability is achieved through multiple data centers and redundant systems that we'll discuss in a later session. Predictability is another significant advantage. With cloud services, you can anticipate costs and performance more accurately. This predictability helps you manage your budget and resources effectively, ensuring that you get the most value from your investment. Security is a top priority for cloud providers. Azure offers robust security measures, including encryption, access controls, and regular security updates. These features help protect your data and applications from threats. Governance is also enhanced with cloud services. Azure provides tools and policies that help you manage compliance and regulatory requirements. This helps to ensure that your organization adheres to industry standards and best practices. And lastly, manageability is a major benefit of using cloud services. Azure offers a range of management tools that simplify the administration of your infrastructure. These tools allow you to monitor performance, automate tasks, and manage resources efficiently. Now, let's discuss our last learning objective on the different types of cloud services. The first type of cloud service is called Infrastructure as a Service, or IaaS. IaaS is the most basic category of cloud computing services. With IaaS, you can build a pay-as-you-go IT infrastructure by essentially renting servers, virtual machines, storage, networks, and operating systems within Azure. This model allows you to avoid the costs and complexities of buying and managing your own physical servers and equipment. And instead, you get an instant computing infrastructure that is provisioned and managed over the internet. This flexibility enables you to scale your resources based on your needs, making it a cost-effective and efficient solution for many organizations. Platform as a Service, or PaaS, provides an environment for building, testing, and deploying software applications. This model helps you create applications quickly without the need to focus on managing the underlying infrastructure. By using PaaS, you can streamline the development process, allowing your team to concentrate on writing code and delivering high-quality applications efficiently. This approach not only accelerates development, but also reduces the complexity and cost associated with managing the infrastructure. Some examples of services that are considered platform as a service include the Azure App Service, which allows you to host web applications, as well as the Azure SQL Database Service, which allows you to host databases in a SQL environment. When you provision these services, they come with all of the necessary infrastructure required to host the service. So you can focus on configuring and managing the service itself without needing to manage any of the underlying infrastructure. Software as a service, or SaaS, delivers software applications over the internet, usually on a subscription basis. With SaaS, you can access applications through a web browser without needing to install or maintaining any software on your devices. This model provides ready-to-use applications that are managed and updated by the service provider, which means you always have access to the latest features and security updates. SaaS is ideal for businesses that want to use software without the hassle of managing it. This offers convenience, scalability, and cost effectiveness. And by leveraging SaaS-based services, organizations can focus on their core activities while enjoying the benefits of modern cloud-based applications. So to recap, IaaS is the most flexible cloud service. With IaaS, you configure and manage the infrastructure for your application. This means you have control over the virtual machines, storage, and networks, allowing you to tailor the infrastructure to meet your needs. PaaS, on the other hand, allows you to focus on application development. The platform management is handled by the cloud provider, so you don't have to worry about the underlying infrastructure. This enables you to concentrate on writing code and delivering high-quality applications efficiently. And SaaS operates on a pay-as-you-go pricing model. Users pay for the software they use on a subscription basis. This model provides ready-to-use applications that are managed and updated by the service provider, ensuring that you always have access to the latest features and security updates. As you consider and evaluate public cloud services, it's critical to understand the shared responsibility model and which security tasks the cloud provider handles and which tasks you need to handle. The workload responsibilities vary depending on whether the workload is hosted as a software as a service, platform as a service, infrastructure as a service, or within an on-premises data center. In an on-premises data center, you own the entire stack and you are responsible to create and manage everything from the physical data center and hardware all the way up to managing all the data. As you move to the cloud, some of these responsibilities transfer to Microsoft. For example, if you use services that are considered to be infrastructure as a service, Microsoft takes care of the physical hardware. When you use PaaS-based services, we start to manage more of the implementation of the service. And then with the SaaS model, Microsoft takes care of almost all the implementation to host the service. Regardless of the type of deployment, you always retain the following responsibilities: data, endpoints, accounts, and access management. This means that while Microsoft handles certain aspects of security infrastructure management, you must ensure that your data and access controls are secure and still properly managed. That brings us to the end of our first session, where we introduce the cloud and its benefits, as well as the different types of cloud implementations. Then we covered the different types of cloud services and finished with an overview of the shared responsibility model. This concludes session 1. We'll take a quick 10-minute break before we start with session 2 on Azure Architecture and Azure Compute Services. Enjoy your break and see you soon. Welcome back from the break. In this session, we'll be discussing some of the core Azure architectural components, as well as introduce different compute options within Azure. More specifically, in our first learning objective on Azure architectural components, we'll cover what regions and availability zones are, followed by what subscriptions and resource groups are. After that, we'll cover our second learning objective on compute, where we'll talk about some of the different compute types in Azure, as well as some of the options on how you can host applications. Let's get started with our first learning objective on Azure architectural components. Azure regions represent a collection of data centers that provide flexibility and scale for your applications and services. These regions help preserve data residency, ensuring that your data stays within specific geographic boundaries as required by regulations or business needs. When selecting regions, it's important to choose the closest region to your users to help reduce latency and improve performance. Additionally, you should be aware of region deployment availability to ensure that the services you need are available in your preferred region. While most services are region specific, there are also global services that are region independent, such as Microsoft Entra ID. Global services provide consistent functionality regardless of the region where they're being used. Azure availability zones are physically separated data centers within an Azure region. Each availability zone includes one or more data centers equipped with independent power, cooling, and networking. This setup acts as an isolation boundary, ensuring that if one availability zone goes down, the others will continue working within that region. This design helps maintain high availability and resilience for your applications and services, minimizing the risk of downtime and ensuring business continuity in the event of a data center failure. Each Azure region is paired with another region that is at least 300 miles or 500 kilometers away from each other. This distance helps to mitigate the risk of natural disasters or other localized issues affecting both regions simultaneously. Some services provide automatic replication to the paired region, enhancing data redundancy and availability. In the event of an outage, recovery of one region is prioritized out of every pair, ensuring that services can be restored as quickly as possible. Additionally, Azure system updates are rolled out to paired regions sequentially, not at the same time, to minimize the impact on availability and ensure continuous service. Azure Government is a physically separated cloud service that meets the security and compliance needs of U.S. federal agencies, state and local governments, and their solution providers. It operates as a completely separate instance of Azure, ensuring that it's physically isolated from non-US government deployments. This isolation helps maintain the highest levels of security and compliance. Additionally, Azure Government is physically accessible only to screened authorized personnel, which provides an extra layer of protection for sensitive government data and applications. Azure China is notable for being China's first foreign public cloud service provider in compliance with government regulations. It operates as a physically separated instance of Azure Cloud Services and is managed by 21 VNet. This separation ensures that all data stays within China, maintaining compliance with local regulations and providing a secure and reliable cloud environment for businesses operating within China. Let's take a closer look at the Azure infrastructure around the world with a little demo. All right, so let's start off by going to, I think this is just a great tool to go and view what data centers look like all over the world. So we're going to go and look at this global map, right? So let me get this in here. It's datacenters.microsoft.com/globe/explore. Let me fix my typos here. Data centers. And what this is an interactive globe of what Azure basically looks like, around the planet. You can see, a lot of our cabling. We do have, one of the hugest networks in the world. It's all dark fiber, later across the planet. But you can see things like all the regions around the world, things like point of presence, stations. You actually see satellites in there as well. We do have Azure Space. and you can look at this. You can zoom in on different places and see a lot of it. So you can filter. So let's come down here. Let's remove everything and just add regions. There we go. And we can look at regions around the world. So let's get back over to towards North America, for example. We can see all the various regions around the world. We can hover over top of them and get a little more information on them as well. So if we click on them, you can see this is West US 2. We see when it was opened. It supports availability zones, like I just highlighted there, and it's pretty good. So let's add some other things here. We add all the networking components in here. You see things like edge zones, network point of presence, like POP environments. And these are really useful for things like, content delivery networks and all that. So you see that these are located in a lot more locations around the world. And the idea is that we can have, things like caching environments actually be closer to the people that are going to consume that. So let's close that, right? And you can look at a lot of these environments and just play around with it. It's actually pretty amazing. We also have sustainability projects, right? Because one of the things that we're very big on in Microsoft here is to be carbon neutral. And so you see that we actually support a lot of these solar, wind farms, and all that to help supply power to Azure, because it's we got to run on power, and that's part of this map here, this interactive map as well. Let's see some other things. You can take a tour of some other things in here as well. Like if you want to look at the data center itself or Azure space, you can actually go into some of those. The data center is a little more complex because you're going through the data center. So let's look at Azure space. And I just love this view. So a lot of people don't know that Microsoft, we do have a space program. It's not we're much more about communication and all that, but you can check that out and get a little blurb on it as well. So that's kind of neat. So let's go back to the globe. And yeah, pretty cool. All right, with that, let's go back to our presentation and continue on. Azure resources are the essential component that you use to build cloud solutions. These resources include storage, virtual machines, networks, and more. Storage allows you to save and manage data efficiently, while virtual machines provide the computing power needed to run application services. Networks enable communication between different resources, ensuring that your cloud solutions are connected and functional. By leveraging different resources, you can create scalable, reliable, and efficient cloud-based applications and services. Whenever we create a resource in Azure, we add it to what's called a resource group. A resource group is a way to manage and aggregate resources into a single unit. Resources can exist in only one resource group at a time, ensuring clear organization and management. Resources within the same resource group can be located in different regions, providing flexibility in deployments and management. Additionally, resources can be moved to different resource groups as needed, allowing for easy reorganization. Applications can also utilize resources from multiple resource groups, enabling better management and scalability of complex solutions. Azure subscriptions provide you with an authenticated and authorized access to Azure accounts. What this means is that whenever you access a resource in a subscription within Azure, you'll need to be authenticated by the tenant that the subscription belongs to, as well as authorized using the permission set within the subscription that manages the resource. Subscriptions also serve as a billing boundary, allowing you to generate separate billing reports and invoices for each subscription. This helps in managing costs and tracking expenses much more effectively. Additionally, an Azure subscription also acts as an access control boundary, enabling you to manage and control access to the resources within that subscription. An Azure tenant can have one or more subscriptions, providing flexibility in how you organize and manage your resources. Many organizations will use multiple subscriptions to control access and billing to different environments. For example, you might have 3 subscriptions for the same organization, broken down into production, test, and development subscriptions. This approach helps to isolate and manage environments much more effectively. Azure management groups are an effective way to organize and manage multiple Azure subscriptions. Management groups can include multiple subscriptions, allowing you to apply policies and access controls across all of them simultaneously. Subscriptions inherit the conditions applied to the management group, ensuring consistent governance and compliance. Azure supports up to 10,000 management groups in a single directory, providing extensive scalability for really large organizations. Additionally, a management group tree can support up to 6 levels of depth, enabling you to create a hierarchical structure that aligns with your organizational needs. Let's take a moment to do a demo on how to create a resource in Azure. All right, so in this demo, what we're going to do is we're going to open up portal.azure.com. I've already opened it up here, so just to point out that this is the URL that we're going to. And we're going to go and create a resource. It's pretty easy. So just click on create a resource, and we're going to create a virtual machine. I could create it right here, but I want to show you how to search for it. So that way we can find any resource. So I'm just going to type in virtual machine, right? Go ahead and continue through the search. And this will take us to the marketplace. Let's close that so we have a little more on the screen. And we can use this to go through a lot of resources, like 12,000 plus resources that are pinged for virtual machines. I want the Microsoft one, so this is this one right here. So let's create that. Now, when we're creating the virtual machine, this is where we get into creating a resource, and we start setting all of the settings for this resource in particular. So across the top, the networking and all that. So any resource, every resource really has to belong to a subscription, so we pay for it. We also want to put it in a resource group, so we're going to create a new one in this case because resources need to belong to resource groups so we can manage them and group them together. So let's give this a name. Let's say Azure Demo. Oh, I need to get rid of that space there. There we go. And click on OK. It should be good. Make that. And next, we're going to have to give this virtual machine a name. So let's go with something like my VM. And let's see. Yeah, we'll keep the dash in there. And then where do we want it, right? So what region around the world do we want it? And even if the resource group that it belongs to is somewhere, we don't have to put it in the same resource, in the same location as our resource group. So let's put this, how about, since I'm a little friendly with this area, let's go to Canada with Canada Central. And then, there's a lot more settings after this, like availability options. Do we want to support availability zones? And where does this one want to live? What kind of virtual machine is it? So this image and, the architecture and everything. We're not going to go through all of the settings here. That's really for another course for another day. This is just really kind of to represent that, hey, yes, we can create a resource. Now, because we're making a virtual machine, we need to set the security on it. I'm going to, just so you know, for Windows and all that, especially, we can go and put in the username and the password for that, that root user, or that in Windows, the admin user. So let's put in the super secret password, talking and typing at the same time. Hopefully these two match. There we go. It looks like they match. That's great. And for this one, we're going to take a lot of the defaults out of this. We could go through and set up like the disks and the networking, all that. So this looks great, I think. So the disk there, let's go and just make this one, right? So using a lot of the defaults. Okay, and also while this is creating, you would have noticed that there is the estimated monthly cost over here on the right-hand side. So you can kind of see from the settings, what this should roughly take. Now on the review and create page, this is really going to review it and validate everything I'm doing first, make sure I'm allowed to do it. And then we'll have to hit the create button and say, okay, yeah, that looks good. Now let's go and create it. Now this will take a tiny bit to create, not too long because it's a pretty small machine. But at this point, we're submitting the deployment over to the resource manager. The resource manager has accepted it at this point. The deployment's going on. So we're just watching this deployment go. And some resources go very, very fast. Some resources take a lot longer. Virtual machines, we do need to move images and all that. But there's a little more to virtual machines that I'm going to show you this in just a minute. All right, so as you can see, there's a lot of resources here. But this one should go fairly fast, and we'll look at these resources in just a minute. There we go. Okay, so this is done now. So let's go to this resource and see this. See what we created. So when we go here, we get the Azure view of this resource, and we can see we can connect to it. We can start working with this virtual machine. It's already started, and we can start really using it for this. So one of the things we want to show you is in the resource group. So if we open up the resource group, that's all I've done here is just to open up that Azure demo resource. We see our virtual machine, but we also see a bunch of other things. So like I said, virtual machines can't really exist without things like the IP address, that we use to connect to it, the network security groups to help secure it, the network that it needs to communicate on. So when we create this, a lot of those settings from the virtual machine were to go and create this, but it if we leave it at the defaults, it's going to ensure that these are all created for us. So this works, including our disk. Looks good. So with that, let's jump back over to our presentation. Now, let's get into our next learning objective on Azure Compute. Azure Compute represents on-demand computing services that provide a variety of different types of computing resources and include things such as disks, processors, memory, networking, and operating systems. One of the core compute types are virtual machines, which allow you to create and manage virtualized environments. These virtual machines, or VMs, can run different operating systems and applications, providing flexibility and scalability for various workloads. Next, we have app services, which enable you to build, deploy, and scale web apps and APIs quickly. With app services, you can focus on your application code while Azure handles the infrastructure to host your web app, which provides high availability and security. Container instances are another example of Azure Compute Services. They allow you to run container-based applications without needing to manage the underlying virtual machines. This makes it easy to deploy and manage containerized applications, providing a fast and efficient way to run simple container-based workloads. Azure Kubernetes Services, or AKS for short, is a managed Kubernetes service that simplifies the deployment, management, and operations of Kubernetes clusters. AKS provides automated updates, monitoring, and scaling, making it easy to manage containerized applications at scale. And lastly, Azure Virtual Desktop offers a desktop and app virtualization service. It allows you to deliver a full Windows experience to users, providing secure and remote access to applications and desktops from any device, while hosting the underlying compute, all within Azure. Azure virtual machines are software emulations of physical computers. They include virtual processors, memory, storage, and networking, and provide the essential components needed to run applications and services, just like they're running on a physical server. As an infrastructure as a service based service, Azure VMs give you total control and customization over your compute environment. You can configure the virtual hardware to meet your specific requirements, install and run any software you need, and manage the system as you would with a physical server. This flexibility makes Azure VMs an ideal solution for a wide range of use cases, from development and testing to running production workloads. Azure Virtual Machine scale sets provide a load balanced version of multiple virtual machines that can automatically scale in or out whenever needed. So when resources need to increase, the scale sets can scale out, adding more virtual machines to handle the additional load. Conversely, when the resource needs are lower, the scale sets can scale in, reducing the number of virtual machines, which in turn helps save on costs. This dynamic scaling ensures that your applications have the necessary resources to perform optimally while maintaining cost efficiency. Azure Virtual Machine availability sets ensure high availability for your applications by grouping virtual machines in a way that protects them from hardware failures and maintenance events. Update domains keep virtual machines grouped so they can be rebooted at the same time without causing an overall outage. This means that during planned maintenance, only a subset of your VMs will be rebooted, ensuring that your application remains available. Fault domains, on the other hand, group virtual machines based on common power and networking. This protects your VMs from hardware failures, since VMs in different fault domains are placed in different racks, each with its own power and network resources. By using availability sets, you can ensure that your applications are resilient and can withstand both planned and unplanned outages. Let's take a closer look at virtual machine scale sets with a demo. All right, so in this demo, what we're going to do is we're going to go and create a virtual machine scale set. And so we're just here in the Azure portal, but just to really emphasize that we can do things many different ways, I'm going to go do this with the Cloud Shell. So let's open this up, and we're going to provision our virtual machine scale set, everything that we need, and handle that mostly in here. So let's get a prompt in here. And I do have a lot of these commands already set up, so just to save you from watching me type. So I'm just going to go and grab those commands. The very first one is this one, group, AZ group create. So all that we're really doing is we're making this resource group, right? Called my resource group. It's going to be in Canada Central. It's very fast to make that, so we're already back to the prompt. And this next one, I'm going to grab the command here. We're going to create a virtual machine scale set, right? So VMSS create, and then it's just a lot of the settings for this. So my resource group, for where we're going to put it, we're going to call it my scale set. We're also going to have the admin user be Azure user, and we're going to make sure that it's located in Canada Central. So that's going to go. Now this will take a little bit. If you recall the earlier demo on virtual machines, the virtual machines, a virtual machine takes a little bit, but also has a bunch of other resources that are creating with it as well. So this is currently running. It needs to make all those resources. Virtual machine scale sets, just as a reminder, it's one or more machines. So we can have 2, 3, 10 virtual machines all working together to provide kind of that same compute, to handle a particular workload. So the real magic behind this is its ability to scale, and that's what we're going to do in a little bit. So this does take a little bit to go. Shouldn't be too bad. It's a relatively small machine here, so hopefully this gets created fairly quick. Virtual machine scale sets, they're really powerful because it has a load balancer built into it. So it's one endpoint that people consume to get it. Oh, there we go. So it didn't take too long. There's a virtual machine scale set created. And with that, we can see that the result of this, we see all of the settings that were created. So it's all the JSON coming back and say, hey, this is finished. Okay, so next, we're going to go and configure the policy for auto scaling. So we're going to first create the policy, and this is AZ Monitor auto scale create, and this is really just to give some high level settings like we're going to put this policy in the resource group. It's going to be for this particular resource. It's our virtual machine scale set name I just highlighted. It's going to be for a virtual machine scale set. And we're gonna name it, just name it auto scale, and then all of these properties are just going to be like the limits on auto scaling. So this isn't really doing the auto scaling; it's setting up this profile for it. So let's get this going, and then we'll be able to set some rules with this to turn around and actually specify how this is going to trigger. All right, so that's created. That goes really fast. You can see the results there. Now let's go and add 2 rules. We'll start off with a rule to scale out. So we're gonna, add more machines to this. So let me grab the command here. So here's this one. You notice it's auto scale rule create, right? So this is creating a rule. It's for the profile that we just set up. The name was auto scale. We just called it that. And then here's the rule: percentage CPU greater than 70 average, so 70% average over 5 minutes. And what we want to happen is to have that scale out, to scale out with those extra 3 machines. So that scale out 3 was for that. So that's already done. You see the scale action right there. That last value is 3. So if we go over 70%, we'll add it. Now, the next one is we're creating a rule to scale in. So if things calm down, we're going to do that. So again, rule create. It's also targeting that same profile. The difference is that the rule is going to be say, hey, you know, if things slow down, percentage CPU less than 30% average over 5 minutes, let's scale it in. Let's reduce the number of machines by 1. And it's going to calculate that, you know, periodically and say, oh, no, we should drop 1. Oh, now we should drop 1. And these rules go in pretty fast. So that's all done, you know, with that. Now, the next part here, this is all done, right? We have auto scaling rules, so that virtual machine scale set will react to it. The next part is we want to go and provide some load to it. So what we're going to do is we're going to connect to virtual machine scale set. So I'm just going over to the resource group where we created it. I'm going to come down to the scale set itself. Let's open that up. We need to find out what its IP address is, for example, and then we're going to connect to it, and we're going to make those virtual machines do some stuff so we actually trigger the scaling. So here's the public address. We're going to grab that. We're going to need that. And we're going to go back over to the Cloud Shell here. And what we're going to do in the Cloud Shell is we're going to connect to that environment. So we're going to do you know, a secure shell, because these are Linux-based machines in this case. So it's Azure user, that's our admin user, and then we're going to connect to that IP address that we just grabbed. And we're going to use port, this might seem a little unusual, but port 50,000 in here. Now, the load balancer in front of this just defaults to port range 50,000. And that port range will map to 22 in this case. So we're going to say, yep, let's connect to it. And we now have a shell to one of the machines that are in the virtual machine scale set. Now, this next part, we're just going to get it to do something. So I'm just going to grab a little bit of code. We're going to do an app install for an app called Stress. So it's simple. We're just making the virtual machine kind of do something to stress it out. So the CPU goes really high. So we just had to run that. One of the machines in here is currently, you know, stressing out. It's slowly building a bunch of, right now it's installing packages, but it's going to drive the CPU up, right, for that. This is going to run. We do have more than one machine. So when we created this virtual machine scale set, we have 2 instances when you created it. So what we're going to do is we're going to connect to it again. And just because we just created it, these you know, the ports that we're using is going to be sequential. So let's do a Cloud Shell. Let's make sure I grab that IP. Let's grab that Cloud Shell again. And oh yeah, this one's going. So let's make a new session. We don't want to disturb that one. And so for this, we're going to jump back in here. We are going to connect in the same way. We're going to do the same type of workload. The only difference is really we're going to use a different port number. Now, there is a way to go and look up what ports are being used, you know, by the different instances. This changes because we just created. I know that the next one is actually going to be it's out of a range from 50,000 above, right? So it'll go 50,000, you know, 50,001, 50,002, 3. So oh yeah, and I'm kind of jumping ahead. The 3 doesn't do that because we don't have that many machines. I was thinking we had a bigger one. So 50,001, just correct that, should give us the connection to the second machine, which it did. All right, so we're back and logged in here. We're going to do the same thing. We're going to install that stress application and get it running. So now we have both machines are going to spike their CPU. And hopefully what we should see is that our auto scale rules will actually apply. So we had those 2 instances, right? So if we check out the instances here, We should see our 2 instances and see that go. We can control scaling and everything here in the browser too. So, the scaling's there. But yeah, there's our 2 instances. I'm jumping around a little bit here, but this is working away in the background. We just need to do it. Now we can monitor this a number of ways. So metrics, we can look at the CPU load that's on here. So when we're actually doing this real world, we do want to sit and monitor and see how these virtual machines react, from load and all that, so we can react appropriately. So I just changed this around really quick to percent CPU. This is the average for the scale set, so it's still really low. There's a little bit of a delay here, and those threads are just still spiking and all that. So, it's this would actually reflect those numbers pretty good. And so scaling, all the settings I mentioned before, the auto scale setting that we set is reflected there. So let's go back and let's look at the instances and see if we have the auto scaling operation happen. Now we should see this go from 2 machines to 5 machines because we set this to add an additional 3. One thing about this view is this view doesn't refresh automatically. So if you're sitting here and staring at it, this will take some time to have this happen. But if you're sitting here and staring at it, even if the auto scaling actually took place, you would have to refresh this screen to get the update on the screen. That's by design, by the way. I get asked about this a lot. The reason is because that refresh process actually takes adds to the load in the background, because we got to pull all the information from it. So a lot of places in Azure just don't do automatic refreshes very intentionally. Anyway, so at this point we're just waiting. We did configure it to scale after 5 minutes of workload. We usually want to see that happen over a period of time. It's actually more accurate to do it. We're also doing this with only 2 machines and going to 5. A lot of the times when we do scale sets, we're typically working with larger, think smaller machines with a larger number of nodes. So we can actually have scaling happen a little more smoothly, different times. Anyway, at this point, we're just waiting. And hopefully we see our skill set work. Now, just to speed things up, because I'm sure nobody wanted to watch this for 5 minutes, I actually have one of these. I triggered this earlier to make this scale. And so with that, hoping that we can see this a little bit faster. So eventually. All right, let's check this out. Let's hit the refresh. If I'm timing it right, hey, perfect. I got it right on. So you see that there's one still creating. I just happened to catch this, while it was still scaling. We see that we have an additional 3 nodes. We have 5 in total. 2 of them have already finished their startup. 1 is just finishing creating, and that's what we want to see. So, just triggering this a little early so we didn't have to wait, really paid off here. We refresh again. Let's see if that other one finished. Yeah, there we go. You see, in this case, all 5 are up and running. All right, with that, let's go back to over to our presentation and continue on. Azure Virtual Desktop is a desktop and app virtualization service that runs in the cloud. It allows you to create a full desktop virtualization environment without having to run additional gateway servers. This simplifies the deployment process and reduces the risk of resources being left behind. For example, if we were to deploy an application to a user's laptop, the deployment is more complicated since we need physical access to the device. And on top of that, there's a chance that the laptop might become lost or stolen, effectively having the resource left behind, right? That's an example of that. Additionally, Azure Virtual Desktop supports true multi-session deployments, enabling multiple users to access the same virtual machine simultaneously, which can help reduce resource utilization while still providing a seamless experience to its users. Azure containers are lightweight, virtualized environments that don't require operating system management. Since these are smaller and lighter than virtual machines, it's much easier to implement changes on demand, like scaling more rapidly than virtual machines are able to. Azure container instances are a PaaS offering that runs a container or a group of containers in Azure, providing a simple and efficient way to deploy and manage containerized applications. Azure Container Apps are similar to container instances, but offer additional capabilities such as load balancing and scaling, making them ideal for applications that need to handle varying levels of traffic. Azure Kubernetes Service, or AKS, is an orchestration service for containers designed for distributed architectures and large volumes of containers. AKS simplifies the deployment, management, and operations of Kubernetes clusters, providing automated updates, monitoring, and scaling to ensure your containerized applications run smoothly and efficiently within the AKS cluster. Let's compare Azure Compute Services, starting with virtual machines. Azure Virtual Machines are software emulations of physical computers, providing virtual processors, memory, storage, and networking. They offer total control and customization, making them ideal for a wide range of use cases, from development and testing to running production workloads. Next, we have Azure Virtual Desktop, a desktop and app virtualization service that runs in the cloud. It allows you to create a full desktop virtualization environment for users. These can reduce the risk of resources being left behind and supports true multi-session deployments, enabling multiple users to access the same virtual machine simultaneously. And lastly, we have containers. Azure containers are lightweight, virtualized environments that do not require operating system management and can respond to changes on demand much more easily. Azure Container Instances are a PaaS offering that runs a container or a group of containers in Azure, providing a simple and efficient way to deploy and manage containerized applications. Azure Container Apps are similar to container instances, but offer additional capabilities such as load balancing and scaling. Azure Kubernetes Service is a full orchestration service for containers, designed for distributed architectures and large volumes of containers. AKS simplifies the deployment, management, and operations of Kubernetes clusters, ensuring your containerized applications run smoothly and efficiently within an AKS cluster. Azure Functions are another compute option in Azure that is platform as a service based and can use serverless computing, allowing you to run event-driven code without managing server infrastructure. This approach can help to bring developers closer to business logic by abstracting away the underlying infrastructure. Also, whenever we refer to serverless computing, it doesn't mean that there aren't any servers. Rather, it typically refers to the ability to provision that compute very rapidly on demand, rather than provision the compute beforehand. The code in an Azure function is triggered by various events, such as HTTP requests, timers, or file uploads, and the infrastructure can scale instantly to meet demand. Since you only pay for the resources used, serverless-based functions can be very cost-effective to host. It's important to note that serverless computing requires a different mindset and isn't suitable for every scenario. That being said, with Azure Functions, you can focus on writing the code for your service, while Azure handles the infrastructure based on the events that trigger your functions. This makes it a highly efficient and scalable component for many solutions. Azure App Services is another compute option in Azure. Azure App Services provide a fully managed platform that allows you to build, deploy, and scale web apps and APIs quickly. It also supports a variety of programming languages, including .NET, .NET Core, Node.js, Java, Python, PHP. This PaaS-based service provides enterprise-grade performance, security, scaling, and compliance for hosting web-based applications, making it a reliable choice for developing and managing them. Similar to Azure Functions, with Azure App Services, you can focus on your application code, while Azure handles the infrastructure, providing a seamless and efficient development experience for web-based applications. This brings us to the end of our second session. In this session, we covered some of the core architectural components of Microsoft Azure, including how it aligns with managing your services within Azure. We also reviewed some of the different ways the compute is implemented within Azure, such as Azure Virtual Machines and container services. We also spent some time on comparing some of the compute options as well. With that, let's take a 10-minute break before we resume with session 3, where we'll be covering Azure networking. Enjoy your break and see you soon. Welcome back from the break. In our third session, we'll be introducing Azure networking. More specifically, we'll be introducing what Azure networking is, followed by a discussion on virtual private network gateways. Then we'll introduce what Azure ExpressRoute is before we finally wrap up with Azure DNS. So let's get started with our one and only learning objective for this session on Azure networking. An Azure Virtual Network, or VNet for short, is a fundamental service that allows Azure resources to communicate with each other, to the internet, and/or on-premises networks. It provides the building blocks for your private network within Azure, similar to a traditional network you would operate in your own data center, but with the added benefit of Azure's infrastructure, such as scalability, availability, and isolation. VNets enable you to create a logically isolated network in Azure. You can define your own IP address space, create subnets, and configure route tables and network gateways. This allows you to control the network topology and manage traffic flow within your Azure environment. Public endpoints on a VNet are accessible from anywhere on the internet, allowing external users to access your resources. Private endpoints, on the other hand, are accessible only from within your network, providing an additional layer of security. Subnets allow you to segment your VNet into smaller, more manageable sections. Each subnet can be assigned its own IP address range, and you can deploy Azure resources within specified subnets. This segmentation helps improve IP address allocation efficiency and enhances security by isolating different parts of your network. Network peering is a way that we can connect two VNets together to communicate, allowing resources in different VNets to communicate with each other. This is useful to create a global network architecture where VNets in different regions can be connected very seamlessly. Azure Virtual Networks also support hybrid networking scenarios, allowing you to connect your on-premises network to your Azure VNet using a virtual private network, or VPN for short. Or we can use Azure ExpressRoute. We'll introduce both of those services shortly. Both of these options can create a secure and reliable connection between your on-premises and cloud environments, enabling you to extend your data center to the cloud. Let's take a closer look at networking in Azure with a demo. All right, so in this demo, we're going to look at controlling the network access to these resources, in this case, a virtual machine. So I'm going to open up the Cloud Shell. We're going to do this in Bash as well. See if we can get everything working and connected all with the command line, right, using the Azure CLI. Okay, so I'm cheating again. I'm copying and pasting some commands in here. This very first one, just going to make a quick edit here. We want to set this to the resource group name that we're using for these demos. So this is Azure Demo. And what this command is simply doing is it's going over to our virtual machine that we created earlier, and we're going to list the IP addresses. We're going to grab one of those and simply store it in the variable IP address, right? So let's go and run that. And just to see what the IP address is, let's just echo this back out on the screen, make sure we got the address okay. And sure enough, that's the public address for our virtual machine. And again, we have these configured for public addresses right now to make things simple. All right, so what we want to do is I just want to show you that currently this machine is not accepting any incoming requests. So we're going to use curl to try and connect to this IP address with HTTP. And we're going to set a connect timeout for 5 seconds. So it's not going to wait forever trying to connect. And the point is this should fail, right? This should fail. Currently, and this is what the default is, port 80 is blocked. It does not accept it. And so you see the fail come back. Okay, that's perfect. That's exactly what we wanted. And so, port 80, not currently accepting anything. So what we're going to do is we are going to go and enable the access to that virtual machine over port 80. So we're going to open up that network port. So next up, what we're going to do is we are going to start playing with NSGs, right? These are the network security groups. So let me just edit this and make sure we're targeting the right resource group where these are. So I want to look at the resource demo group, and we see that we have a network security group for my VM, all right, NSG. So this is controlling the ports that are open or allowed to communicate in and out of that virtual machine. So once we see the NSG, what we're going to do is first we're going to look at the rules, and then we're going to change one. So we want to make sure that we target the right NSG. So we're going to look at the rules. I'm just changing the resource group again for the resource group that we're using for this demo, Azure demo. And what we should get is the rule list. So let's see this go. And we'll see that the current rules do not allow, or hopefully they don't allow, port 80. So if I scroll up here, this is the only rule that's in there, is to allow port 22. And it is inbound, right? So any incoming traffic on port 22 is allowed. Basically, the name here is SSH because port 22 is that. So with that, what we want to do is add to this list. And so the next command, let me go grab it. This is where we're going to create a new rule. So a little bit editing here as well. Make sure I just got to change this NSG name because I used a slightly different name. And also the resource group name again. That's what happens when you do a lot of these demos. You have some template code. This command is creating a rule on that NSG. So we're going to add one. And more specifically, we're targeting the NSG and everything. But we're going to call it allow HTTP. And we are going to allow port 80 here. So as a destination port 80, and we're going to set it in the allow list, right? So we're going to give it a thumbs up. All right. So once we do that, this doesn't take too long. And what we're going to do is I'm just going to rerun the command to show the list of rules, just to show you that it was in fact added. And so if I look at the same list of rules that only had port 22 earlier, so that's the one that's further up there, we now see another one that allows port 80, right? So port 80 right there. It is inbound. It has name, allow HTTP, all the settings that we did on. Okay. So now the next thing I'm going to do is I'm going to test the connection to it. So I'm going to do that same curl command that failed earlier. I'm going to try and communicate over port 80, and this time, bingo, right? We have a positive communication here. So we got results back. That server is actually responding over port 80. So we've effectively opened up that port to that address. And yeah. So now just to highlight, it's not just these commands like curl, it's port 80 that's open. So I'm going to take this IP address and let's go, copy that real quick. Let's put it into another tab. And because it's port 80, it's just a website. We're going to just go to that port, go to that site real fast. And you'll see, welcome to Nginx. That's actually the virtual machine that's running in the virtual machine that we just opened up that port. So this works. Easy as that. All right, let's get back to our presentation and continue on with some more content. An Azure Virtual Private Network Gateway, or VPN gateway for short, is a service that enables you to send encrypted traffic between an Azure virtual network and an on-premises location over the public internet. This ensures that your data remains secure as it travels between your on-premises infrastructure and the cloud. VPN gateways also support sending encrypted traffic between two Azure virtual networks, providing a secure and reliable connection for your resources across different regions. By using VPN gateways, you can create multiple connections to the same gateway, allowing for flexible and scalable network configurations. A common use case for Azure VPN gateways is to establish a secure connection between an organization's on-premises data center and an Azure virtual network. For example, a company might have sensitive data stored in an on-premises database that needs to be accessed by applications running in Azure. By setting up a site-to-site VPN connection, the company can ensure that data is transmitted securely over the public internet, protecting it from any potential threats. Azure Express Route is another way that we can connect an on-premises network to an Azure virtual network. ExpressRoute is done over a private network connection facilitated by a connectivity provider and ensures that your data travels securely and reliably between your on-premises infrastructure and Azure without going over the public internet. By using ExpressRoute, you can achieve higher security, much faster speeds, and more consistent latency times compared to typical internet connections. This makes it an ideal solution for scenarios that require reliable and high-performance connectivity, such as data migration, disaster recovery, and hybrid cloud deployments. ExpressRoute also supports connections to other Microsoft cloud services, including Microsoft 365, Dynamics 365, providing a seamless and integrated experience for your entire enterprise. A common use case for Azure ExpressRoute is in hybrid cloud deployments. For example, a company might have critical applications running on premises, but wants to leverage Azure for additional compute and storage capacity. By using ExpressRoute, the company can create a more secure and high-speed connection between its on-premises data center and Azure. This allows the company to run workloads in both environments and seamlessly move data between them. Additionally, ExpressRoute can be used for scenarios like periodic data migration, replication for business continuity and disaster recovery, helping to ensure that the company's data is always available and protected. Azure DNS is a service that allows you to provide domain name resolution for your DNS domains in Azure using Microsoft's global network of name servers. This ensures high reliability and performance since your DNS queries are answered by the closest available server, reducing latency and improving response times. In terms of security, Azure DNS offers robust protection against DNS attacks, ensuring that your domains are secure and that your data is protected. The service is also easy to use, with a simple interface that allows you to manage your DNS records effortlessly. You can create and manage DNS zones and records using the Azure portal, Azure PowerShell, or the Azure CLI, making it accessible for users with different preferences and skill levels. Azure DNS also supports customizable virtual networks, allowing you to create private DNS zones that are only accessible within your virtual network. This provides additional security and isolation for your internal resources. Additionally, Azure DNS supports alias records, which enable you to map your DNS names to Azure resources. This can make it easier to access your services by using your own DNS names to access the resource. A key feature of Azure DNS is its integration with other Azure services. For example, you can use Azure DNS to manage the DNS records for your Azure virtual network, enabling seamless name resolution for your virtual machines and other resources. This integration simplifies the management of your network infrastructure and ensures that your applications communicate effectively. And that brings us to the end of this session on virtual networking, covering VPNs, ExpressRoute, and DNS. That concludes part 1 of our Microsoft Azure Virtual Training Day on Azure Fundamentals. Let's quickly recap what we've covered so far. In our first session, we introduced the cloud and its benefits, as well as the different types of cloud implementations. Then we covered the different types of cloud services and finished with an overview of the shared responsibility model in Azure. In our second session, we covered some of the core architectural components of Microsoft Azure, including how it aligns with managing your services within Azure. We also reviewed some of the different ways the compute is implemented within Azure, such as Azure Virtual Machines and container services. We also spent some time on comparing some of the different compute options. And then finally, in our third session, we covered virtual networking, including VPNs, ExpressRoute, and Azure DNS. Thank you for joining us so far. We look forward to seeing you for part 2 of the Microsoft Azure Virtual Training Day Azure Fundamentals event. See you soon.